In the summer of 500 BC, the Persian desert reached 45 degrees Celsius. Meat spoiled by noon. Fruit wilted in its baskets. Water turned warm before the morning ended. And the people could do nothing but sweat and fan themselves and wait for night. But on the edge of this same market stood a building. And inside this building, it was cold. Cold enough to chill water. Cold enough, as we will see, to store ice. In the desert, in summer. This is the story of the windcatcher, perhaps the most brilliant machine ever built with no moving parts and no power at all. This is Persia, modern-day Iran, 25 centuries ago. And this is the city of Yazd, built in the middle of one of the driest deserts on earth. Summers here are brutal. Rain almost never falls. And in 500 BC, there was no electricity, no fans, no refrigerants, nothing. Yet people didn't just survive here. They built one of the oldest continuously inhabited cities in the world. Look closely at that skyline. Almost every wealthy home has the same strange feature: a tower. Tall, hollow, and open at the top. Not to let smoke out, but to let the wind in. The Persians called it a badgir, literally wind catcher. The idea may be even older. Ancient Egyptian paintings show similar wind scoops on houses 3,500 years ago. But it was in Persia that the wind catcher became a science and a status symbol. Because in the desert, the greatest luxury was never gold. It was cool air. So, how does a stone tower create it? Meet the man who understands it best, the city's master builder. His tools are mud brick, timber, plaster, and 2,500 years of observing how air behaves. Rule 1. Wind that hits an opening creates pressure. Air is pushed in. Rule 2. Wind that passes an opening creates suction. Air is pulled out. So the engineer divides the tower into vertical shafts. One face catches the wind, the opposite face releases it. Cool air pours down one shaft, floods through the house, and stale hot air is sucked up and out the other. The house doesn't just receive a breeze, it breathes. Inside, the difference is immediate. In the best designs, indoor air could be around 10 degrees cooler than the street outside. But the engineer isn't finished. Because some days, the desert wind doesn't blow at all. On still days, the tower switches jobs. It becomes a chimney. The sun heats the tower's walls. Hot air inside the shaft rises and escapes, and as it leaves, it drags the stale air of the house up with it, pulling fresh air in through doors, courtyards, and cellar vents. Physicists call it the stack effect. The Persians simply called it how a house should work. And then comes the masterstroke. Because Persian engineers had a second invention hidden beneath their feet. The qanat, an underground canal dug by hand, carrying mountain water for kilometers beneath the desert. Some qanat networks ran for over 70 kilometers, entirely in the dark, sloped by hand to a fraction of a degree. Now watch what happens when the engineer connects the wind catcher to the qanat. Air is drawn down a shaft and over the cold underground stream. As the water evaporates, it steals heat from the air, the same physics that cools your skin when you sweat. By the time that air rises into the living rooms, it is not just moving. It is genuinely cold and gently humid. A complete air conditioning system. Silent, self-powered, running day and night for centuries. The family that sweated in the market now sleeps through the hottest nights of the year. But the Persians pushed this technology one step further, into territory that sounds impossible. This is a yakshal, in Persian, an ice pit, a machine for making and storing ice in the desert. Here is the trick. On clear desert nights, the ground loses its heat straight up into the black sky, and temperatures crash. Engineers dug shallow pools and shaded them with high walls so no daytime warmth lingered in the ground. By dawn, on the coldest nights, a thin sheet of ice had formed, in a land where rain barely falls. Night after night, workers harvested the ice and carried it into the yakshal. Inside, a pit deep underground, walls 2 meters thick, sealed with a waterproof mortar of clay, sand, ash, and egg whites. The cone above did the same job as the windcatcher. Hot air rose to its peak and slipped out a vent at the top. Ice harvested in January was still frozen in July. Persians used it to chill water, preserve food, and to make faluda, a frozen dessert of thin noodles and rosewater. Ice cream, 500 years before Rome fell. No compressor, no chemicals, no fuel. Just walls, shade, night skies, and an almost supernatural patience with physics. Today, air conditioning consumes about 1/10 of the world's electricity, and as the planet warms, that number is climbing fast, which is why architects have started looking backward. In Abu Dhabi, Masdar City raised a modern wind tower 45 meters tall to cool its central square. Universities and eco-buildings across Europe and the Middle East now ventilate lecture halls with towers a Persian builder would recognize instantly. And Yazd, the city of windcatchers, is now a UNESCO World Heritage Site, its towers still standing after centuries of summers. The engineer who raised these towers never saw a wire or a motor. He had only wind, water, shade, and the willingness to study them for a lifetime. We tend to believe comfort was invented in the last 100 years. The truth is, we've simply forgotten how much of it was invented in the first 5,000. If ancient engineers could cool a city with wind, wait until you see how Rome moved water uphill for 500 miles.